All right, this is Chapter 5, Section 1. We are going to get into learning more about triangles and being able to work with triangles. I would suggest taking notes. All right. If I'm looking at a triangle, and it's just any kind of triangle, okay? Everybody tells me I yell on this. Do I yell? Am I really loud? Good. All right. I'll be quiet then. Okay. I'm looking at a triangle here. Any kind of triangle. All right. And we're gonna learn some really cool stuff today. If I was to label this triangle, why did it just do that? Come on. A. Really? B. C. All right, I label my triangle ABC. If I take a look at the midpoint, which is the halfway point between A and B, let's say it's right about here. That means this segment here is equal to that segment there. All right? If I look at the midpoint between A and C, let's say it's right about there, that means that this segment is equal to this segment. All right? If I draw a line between those two midpoints, here's the neat thing that happens. This side right here, this segment here, is half the segment of this one. So if I was to draw my midpoint right here and say that this segment's equal to this one, I can also say that it's equal to that. This half of this is equal to that. Half of BC is equal to, let's label this DE. I can say that 1/2 of BC equals DE. Or I can write it like this. BC equals 2 times DE.
Can it be 2DE if you're still times?
Yeah, it can be that. All right? Kind of cool. If I find my midpoints, draw this segment, this is half of this total line down here. Well, what happens if I draw a line here? This is half of this, right? What if I draw this segment here? This is half AB, or it's equal to AD. Let's make this one down here F, okay? So I can say here that DE equals BF, right? BF. All right? I can say that DF equals EC. And I can say that, see what's my next one here? We went DF, this one right here, right? FE, AD or DB, either ones. Let's say AD. Okay. Here's what else is cool. This triangle here is similar to this triangle here. It's just upside down and flipped over. That's smaller. But I can say that this angle right here equals this angle right here.
What about that bottom angle?
This angle right here equals E. And this angle right here, why would you do that? this angle right here equals this angle right here. Kind of cool. Once we find those midpoints, there's a lot of things that happen in this. There's a lot of things that happen in here once we find the midpoints. Okay? Not yet. Anybody still writing? Good? All right. Okay. So if I had a triangle that looks like this, and I drew my, this goes off to my midpoints. All right. This is A, B, C. Let's call this D and E. And I was to tell you that this down here was 20. And I was to tell you this up here is 2x. Can you find out what x is? So it'd be 2 times 2x, right? Twice this equals 20. Or 4x equals 20. X equals 5. See how we can figure that out? See how we do it? No, 4 into 20 goes 5 times. If we divided by 2 here, we'd make this 10, and then we divide this by 2, and we make it 5. This is, yeah, we could say it 2 times DE equals BC. Right? 2 times this equals this. 2 times 2x. In this case, DE is 2x, and our BC is 20. Because I made this 2x up here. Yeah. 4x equals 20. Divide both sides by 4. X equals 5. See how we do that? Good, Jacob. Even with your glasses on. You do? See these problems? If I take a look at the very first one, it says AC. It's down here, right? What's AC going to be? If this is 15, what's AC? 30. All right? If you take a look down here, this is 3x. This is 5x plus 7. What do we have to do? 2 times 3x equals 5x plus 7. Okay? Go ahead and go to work. Do them all.